V. And we can use this to get what the V is, the V of the moving particle, because the moving wavelength is trying to tell us that it's not only light that behaves as a wave particle, that shows wave particle duality, other objects too, like electrons. So we're going to get the velocity of this electron here, and that will be what? V equals to H all over m lambda, and that will be giving us 6.62 times 10 raised to the power of minus 34 divided by mass of electron. The mass of an electron is a constant value of 9.11 times 10 raised to the power of what? Raised to the power of minus 21, minus 31 rather, minus 31. Then times the wavelength, which was given to us as 10 raised to the power of minus 11. Now when we punch that in the calculator, we put it in our calculator, we have 6.62 times 10 raised to the power of negative 34. Don't know why NEPA just gave like this today, sharp. 9.5 by 9.11 times 10 raised to the power of minus 31. 17, sorry, 31 divided by 10 raised to the power of minus 11, negative 11. So that gives us 7.2 times 10 raised to the power of 1, 2, 3, 4, 5, 6, 7. Raised to the power of 7. So V is equals to 7.267 times 10 raised to the power of 7. That's 10 raised to the power of 7 meters per second. So we can now install this into that our formula I wrote before previously. We said our KE equals to mv squared over 2. So that will be equals to m here is the mass of the electron, which is what? 9.11 times. We've gotten our V to be this 7.267 times 10 to the power of 7 squared, then divided by 2. You get that now. So what does that give us? Now put K equals to, so this value square times 9.11 times 10 raised to the power of minus 31 divided by 2. So that gives us a value of 2.4 times 10 to the power of minus 19. 2.4 times 10 raised to the power of minus 19. That's our kinetic energy. That's our kinetic energy. We put that 2.4 times 10 raised to the power of minus 19 joules. That's it. That's it. Hope we get that right. Hope we get that right. Hope we are together. Okay, let's now move on. That's that one for that one. Let's move on. Let's go to that side of the issue.
Maybe I'll try that.
Okay, we're going to move to the next question.
Well, because of the question, let's go on like this.
Okay, so next one now says the work function. Hope we are getting it. Any question you have, take note of it, or you can ask it here on the comment. Now the next one, the work function. The work function of sodium. The work function of sodium metal is 2.3 electron volts. So they've given us one value there. Work function is 2.3 electron volts. You get now? And I told you we cannot solve anything with electron volts. You get? Convert the electron volt to joules, and that means times 10 to the power of 1.6 times 10 to the power of what? Minus 19. That will give us our answer in joules. So I can just put that there. Everything like that is what? Joules. What is the longest wavelength? So they're asking us to find the wavelength that can cause photoelectron emission from sodium. What is the shortest wavelength that can cause photoelectron emission from sodium? It's very, very simple. This is our work function that was given to us already. So, and work function is a form of energy. You get it now? It's a form of energy. So we can just say our work function our work function, which we have been given, is equal to what? HC over lambda. HC over lambda. So we can now, from that formula I wrote there, HC over lambda, we can now get our lambda. We can easily get our lambda now. As you can see, it's not difficult. So what would that give us? I mean, lambda equals to HC times, we're dealing with light, okay, we're dealing with light, yes, photoelectron emission, so that's it times 3.0 times 10 to the power of what? Minus, 8, divided by the work function given to us, which I said we convert to joules, 2.3 times 10 times 1.6 times 10 to the power of minus 19. And that will give us our wavelength. There's my calculator. That will give us our wavelength. So that will be 6.62 times 10 to the power of minus 34 times 3.0 times 10 to the power of 8 divided by 2.3 times 1.6 times 10 to the power of minus 19. And that gives us 5.4 times 10 to the power of minus 7. 5.4 times 10 to the power of minus 7. That's it. That's what it gives us. Is there any question? Is anybody bring any question, comments there? Okay, so we move on now. Problem number 5 says, what potential difference must be applied to stop the fastest photoelectron emitted by a nickel surface? What potential difference must be applied, you understand, to stop the fastest photoelectron emitted by a nickel surface under the action of ultraviolet light? So we're dealing with light. We know that our speed here is going to be what? 6 m. That's speed of light, 3.0 times 10 to the power of 8 meters per second. And they give us the wavelength as 200 nanometer, which is 200 times 10 to the power of 9 meters, and minus 9 meters, nano. You get? Now, this one function I was giving to you, the work now. But now we want to get the energy, you get the potential difference between, and that must be applied to stop the fastest photoelectron emitted. And the fastest photoelectron emitted, we possess a higher amount of energy. So to get that now, all we just say is that what that energy that we're talking about is equal to HC over lambda minus work function. I gave you guys this formula yesterday. So that's what we're going to be using. So let's put all our parameters into place. So 6.62 times 10 raised to the power of minus 34 times speed of light, 3.0 times 10 raised to the power of 8, divided by the wavelength, which is what? 200 nanometers. You get? Minus work function. Our work function given to us is 5.01 EV. Definitely, what you've been asking me now is, I thought I said that you should you should convert this EV to joules. This EV. By the time I get this answer, I'm not going to subtract it because I want to get my final answer. And after getting this answer to EV, so that we're having something EV minus something EV. You understand what I'm saying? So when I punch this into my calculator, I should be having a value of 6.62 times 10 raised to the power of minus 34 times 3.0 times 10 raised to the power of 8. And that will be giving us something that's 1.986 times whatever. I'll divide it by this value here. You guys know how to press your calculator. I shouldn't be teaching you that now. That's 10 raised to the power of minus 9. So it gave me 9.93 times 10 raised to the power of something. I'll check it. 9.93 times 10. 9.93 times 10 raised to the power of minus 19 joules minus 5.01 EV. You know, we want to get the difference in energy. So we cannot subtract joules from EV. We have to convert this one here to EV or convert this one here to joules, subtract. Understand? So let me just convert this one to EV. How do you convert it to EV? I told you already that 1 electron volt is equals to 1.6. That if you must convert this to EV, you have to divide it by 1.6. You have to divide it by 1.6. So I'll be having 1.6 times 10 raised to the power of this. So I'll be having 9.93 times 10 raised to the power of minus 19 divided by 1.6 times 10 raised to the power of minus 19. With this, I've converted it to EV, then minus as electron volts, then minus 5.01 electron volts. When I put this into my calculator, I think it's going to give me 6 point something divided by 1.6 times 10 raised to the power of minus 19. Yes, 6.21. Give me 6.21. So I'm saying my E is equals to 6.21 electron volts minus 5.01 electron volts. This is the energy that was incident on that surface, but this is the amount of energy here that is the motion. So it must so that will be giving us 5 minus 5 point answer minus 5.01. That will be giving me 1.2. That will be giving me 1.2 electron volts. So this is the energy that will be possessed by the fastest moving photoelectron that was emitted. That will be the energy that will be moving with fastest distance. So as you can see, it's not difficult. Very simple, straight to the point, easy. Life is not hard. It's beans. It's beans, of course. Okay, well, let's move on now. Let's move on. In a process called pair production, Now, all these JUPEP questions now, there is a way some of them should come out. Like, they don't expect you to use what you know to solve the question. Use what is in the question to solve the question. Like now, they said a photon is transformed. A photon is transformed into an electron and a positron. Into what? An electron and a positron. So I can come here and say that a photon is equals to electron plus positron based on what was given in the question. Now, on that same question now, they now say that what? A positron has the same mass as the electron. A positron, so I'm saying mass of positron. I'm saying mass of positron, let me call it MP, equals to mass of electron. We know that mass of electron is what? 9.11 times 10 raised to the power of minus 31 kilogram. That's the mass of an electron. So we're saying the mass of the positron is this. So who can now tell me, based on your normal reasoning, what will now be your total mass of the photon? So mass of the photon will be equals to what? Let me write the mass of photon. Since you know that photon comprises of electron and positron, and they told you that mass of electron equals to mass of positron, it will be equals to what? 9.11 times 10 to the power of minus 31 plus 9.11 times 10 to the power of minus 31. Both of them, because both electron and positron are inside and they have equal mass. So we'll be saying our mass of photon will be 2. Since they share the mass of electron and positron have the same value, 2 times 9.11 times 10 to the power of minus 31 kilogram. That is the mass of the photon. Now, they now said that we should find the minimum energy. They said we should find the minimum energy that of a photon that the photon can have for the process to occur. Now, how do we calculate that energy that the photon can have? Now, we're dealing with the photon. We know that the speed we are dealing with here, the speed of the photon, the speed of light, 3.0 times 10 to the power of 8 meters per second. Now, what do we do? What do we do? I can just easily say that what? I can easily bring in our formula of relativity, which I said yesterday, equals to mc squared, the formula that changed the world. That is the formula that changed the world by Albert Einstein. Now, we can now equate our mass, which is the mass of what? Of photon that I've gotten as 2 times this into this formula here, and our speed of light into that one here. And that will give us what? That will be giving us E equals to what's the mass of photon? 2 times this. 2 times 9.11 times 10 to the power of 31 times the speed of light squared. 3.0 times 10 to the power of 8 squared. That will give us the energy. That will give us the energy. That's 2 times 9.11 times 10 raised to the power of minus 31. We have times 3.0. It's to be square. So that will be giving us 1.64 times 10 to the power of minus 13. 1.64 times 10 to the power of minus 13. 1. Energy. But they also had another question under that. They said, what is the corresponding wavelength? If we've gotten our energy, we can get the corresponding wavelength from this formula. E equals to hc over lambda. So making lambda the subject formula, we can say lambda, which is the wavelength, is equals to hc over E. So our wavelength is what? 6.62 times 10 raised to the power of minus 34 times Planck's constant times speed of light 3.0 times 10 raised to the power of 8 divided by what? By E, which is 1.64 times 10 raised to the power of minus 13. Let's have that here. So we are saying 6.62 times 10 raised to the power of minus 34. Yes, and times 3.0 times 10 raised to the power of 8. Yes. Divided by answer. Minus 12 gives us 1.2 times 10 raised to the power of minus 12 meters. Yes, and you can see the answer as 1.2 Armstrong. 1.2 Armstrong. Why? Because times 10 raised to the power of minus 12 is either you call it pico or Armstrong. So that's that one for that one. 300 opinion lens. Let's wait now. Sorry, I'll be rest. So you guys can just be, let me just be showing you. You guys can just be writing the question first. Going through this, the solutions, and see that's the solution for that one there. It's not complex at all. It's not complex at all. You have what you have there. It is what it is, as you can see. So now looking at that next question there, they said a photon of wavelength 0.4 nanometers. The photon has 0.4 nanometers as the wavelength, strikes an electron at rest and rebound at an angle of what? Of 150 degrees to its original direction. Find the speed and wavelength of the photon after the collision. Now the thing there is What concept does that question come from? That's the first question you ask yourself. That question comes from the concept of Compton's scattering. And it will scatter and rebound at an angle, and they've given us the angle. And now the question just wants us to get the what? Speed and wavelength. Now, that speed, this JUPEP question, this particular question, is a question that I'm sure 90% of the students, they will use 30 minutes trying to get the speed when the speed is already there. You don't need to calculate that speed. You just tell them that since it is a photon and photon moves with the speed of light, automatically your speed is what? 3.0 times 10 to the power of 8 meters per second. That's the answer to that one. Your speed is speed of light. The only thing you now have to calculate there is the wavelength of the photon after the collision. What formula are we to use? Let me just show you the demonstration of the formula we are to use now. It's actually not complex. The formula we are to use to calculate that is the wavelength after collision equals to the initial wavelength bracket 1 minus cos theta, where your theta is the rebound angle. That's the formula you have to use. Very simple, Abby. Just enough. So now we will now be having this, which we are looking for, the wavelength of the photon after collision, which is this, equals to initial wavelength 0.4 nanometers. That's 0.4 times 10 to the power minus 9 plus h. We know what h is. H is only 6.62 times 10 to the power what? Minus 34 all over mc. All over mc. When we're given the mass, okay, we're dealing with an electron, so you should know what the mass of an electron is. So the electron is what? 9.11 times 10 to the power what? Minus 31 kilograms. Then times speed of light 3.0 times 10 to the power what? 8 into bracket 1 minus cos 150. And what does that give us? This gives us 6 points. Let me just press this into the calculator. You can do this one first. That's the best of doing it. 1 minus cos 150. We know that cos 150 should give us minus 0 points and this thing minus 0.8660. You get? So I now say 1 minus answer, that gives me 1.800. Then multiply it. It's just, I'm just doing this, multiplied by this 6.62 times 10 raised to the power of minus 34. Then I'll now divide it by everything here, which is divided by 9.11 times 10 raised to the power of minus 31. I wrote 31 minus 31 minus 31. Times 10 raised to the power of 8. You have to be very careful when you're solving this. Now that gives me 0.4 times 10 raised to the power of minus 9. That's this one here. Plus everything like this here gives me 4.5 to ten raised to the power of negative 9. 4 nanometers. So this one is meters, or you say 0.4045 nanometers. I believe you know why. Nano is 10 to the power of 9 minus 9. I can do it like same thing. So as you can see, that question was not tough at all. It wasn't difficult. We just have 3 more questions to solve, and that will be all. Now, there's a question here. A very brilliant question. And this question, when I saw it in the JUPEP past question, the first time I saw the question in the JUPEP past question, that was last year. Like, they had about 3 weeks more to go. And we saw this question. if you are given this kind of question, 90% of students actually might not be able to attempt it because there were no figures given. No figures were given. Please, from problem number 7, okay, I made a mistake. I didn't suppose it's problem number 8, 9, 10. From problem number 8, 9, 10, listen carefully to the procedures. Very, very vital. Very, very vital. Somebody has a question. If you said it's not clear. Please. Okay, I believe it's a bit clearer now. It's because of light. So they took the light. So let's just manage this. Let's just manage. Now, we said, what are the Ke and wavelength of a thermal neutron? 95% of students were not able to solve this question. And the thing is, if you're not a sound student, you might not even be able to attempt it. Of a gas particle, or you can call it a gas, has a temperature. Kelvin. That's the molecule of that thermal neutron is moving. They've linked wave particle duality with what? With our kinetic theory of a gas. So what formula are we to use to get the Ke? The Ke can be obtained by making use of this formula. Ke 3 all over 2 kt 3 all over 2 kt. That's the formula you have to use to get the Ke that they were asking for. Now, can you see, did they put any figure in the question? No, they did not put any number, but you have to get an answer that has number. Your K is your Boltzmann constant. Where K is your Boltzmann constant. Now K is how many? Boltzmann constant is how many? 1.38 times 10 raised to the power of what? Minus 22. Yes. Times 10 raised to the power of minus 22. Joules per mole. Yes, that's your Boltzmann constant. So that's what we're going to insert there, and our temperature has been given. So that means we'll be having Ke, can you see that now? Equals to what? Equals to 3 all over 2 times our K, Boltzmann constant, 1.38 times 10 raised to the power of minus 22 times our T is what? 293 Kelvin. That is 293 Kelvin. So as you can see now, we have those things, we have them there. So what we are just going to do is to punch this in our calculator, and we have gotten the kinetic energy they said we should get. We've gotten the kinetic energy they said we should get, and that will be giving us what? We have 3 times 1.38 times 10 raised to the power of minus 22. So we have 6.07 approximately. 6.07 times 10 raised to the power of minus 20 joules. So we've gotten that. The answer we should also get the wavelength. How do we get the wavelength? The same formula. This equals to H all over what? E what? AC all over E. 6.62 times 34 and speed of 6.07 times 10 raised to the power minus 20. So when we put that in our calculator now, we should be obtaining 6.6 so times 10 raised to the power of minus 34 times 3.0 times 10 raised to the power of 8 raised to the power of 8 So divided by our answer is 6.07 times 10 raised to the power of minus 20. Yes.
Okay. Someone said they cannot see number 8 solution very well.
Number 8, have I started number 8? Okay, like I will start very well. So that gives us lambda equals 3.27 times 10 6 meters. And we know that minus 6 is your micro, so you can write it as 3.27 micrometers. So that's it. So it will focus on the board now so that you can see the solution. So I'll just repeat my statements now. I said that what? A gas neutron molecule with a temperature of 20 degrees Celsius. You get? Has a temperature of 20 degrees Celsius, and that means it's equivalent to 293 Kelvin. That's what I wrote here. 293 Kelvin. See that now? See that now? And I said KE, 3 all over 2 times KT. And that KT there, the other formula there is derived from our gas molecule formula from kinetic theory of a gas. 2 joules per mole. Now we insert all those formulas in all those parameters in this formula, and we get this answer. Then we can now use the formula for energy. Energy equals to EC over lambda. Make lambda solve your formula, you obtain this new formula here. And when you get this new formula, you can get your answer. You should have written it down now. So, solutions. There.
I like it more than once.
So, now, we can move on now. We'll look for person. Like, one person cannot like 10 to 10. Okay, let's move on. Number 8, particle number, problem number 9.
Other people elsewhere.
Yes.
I've seen it.
But like, I don't have access to question.
Yeah, what? Yeah.
So now, a particle of mass m. I think it was last year. If you have your past question with you, you can check it. It was actually last year question, Abi. I don't think you said why I wrote it ABC. That was how it was, one section. You get, I will tell you answer to one question from each section. This was just like one question in a section. So nobody even attempted it. Many students I know, none of them, they said they did not even near that side. And the question is actually easy. That's the truth. You get, it's just that you have to mix your knowledge of sound waves. They brought in the knowledge of sound waves to this topic. This topic is a very, very dangerous topic. That's just the truth. You need the knowledge of everything to solve everything. That's just what I'm trying to say. Now, a particle of mass m is confined. A particle of mass m is confined to the length of the de Broglie wave, which will resonate in the tube. The first thing you would write or tell the examiner, radiation, you tell him that for a de Broglie wave radiation, the tube is impermissive, meaning that it cannot allow any of its molecules, the tube cannot allow any of its molecules
15% battery.
to move out of that particular column. So automatically, what we're going to be having is this our normal style of sound wave distribution, our loop system. So for the first level, L. So it continues that way. It continues that way. You get it? So that's it. The corresponding particle momentum. Now, shape, mass times velocity. But in this aspect now that we're dealing with radiation, wave particle radiation, you know that our momentum is equal to what? H all over what? Lambda. H all over lambda. So that all this formula I'm writing here, I can actually express them as n. I can put n in front of them. Please let's read this very well. N. Where that n is representing integers, and that's like our energy L over n. This one you'll be having L over n. So if you want to put it now, let's look for these two levels. If I put lambda now, if I put lambda as 2L over this thing in this expression, what will I be having? I'll be having H all over 2L over n, which is still equals to NH over 2L. That's for that first level. If it is for the second level now, because you are supposed to do for at least three level, I'm doing two level. You understand the sequence. I'm just going to explain. So you are now having, you have for this one now, for the second level, that means you are substituting this for lambda here. So I'll be having H all over L over N, which will be giving me what? NH all over L. That's it. Let's go to part C. Part C says the corresponding energies. The corresponding energies. What's the formula for our energy? Energy is equals to what? Energy is equals to what? Hc over what? F. No, Hc over lambda. Hc over lambda. So we're going to substitute lambda inside here. We're going to substitute lambda over inside here, and that'll be giving us what? That'll be giving us Hc over lambda. So lambda now will be, we are going to substitute the value of lambdas into that energy place. And that'll be giving us what? That'll be giving us Hc all over, for the first level, all over 2L n. For the second energy level, let me call it an E1. For the second energy level, that's at the second quantum level, you'll be having Hc over lambda there is what? L over 2. L over n. So having divided by L over n, which will be giving us NHc over L. NHc over L. Are we getting the concept now? NHc over L. So that is like those are the values, energy and momentum at different levels. Okay. So now, then the last aspect of that question says, evaluate the energy for an electron in a tube of length 0.5 nanometer. Evaluate the energy. Expression, just for us to substitute our length into the what? Into the expression. And then we get our answer. Or to substitute the substitution. But now, there's sometimes when the particle we are dealing with will not be a wave. It will not be a particle, it will be a particle. That one you'll be using half mv squared. You get that one you'll be using your half mv squared. So let's get that straight. Okay, now so that means for this one I'll be having D. We'll be having D. We'll be having D. As per D now, energy will be equals to what? Energy will be equals to, let's follow this. And imagine our level, because they didn't mention any quarter level, so we're doing the first quarter level. So we're saying 1 is equal to 52. 1 times 6.62 times 10 raised to the power of what? They are really mad. You see your country? Times 10 raised to the power of minus 34. And our C there is what? 3.0 times 10. You people, you are seeing what your country is doing here. You don't have country. So sad. Very, very sad. Okay, so divided by what? N. And they said let N. So they said let N equals to 0.5. Let N equals to 0.5 nanometer. And 0.5 times 10 to the power minus 9. So where is the calculator? That will be giving us 1.6 this 2 times 10 raised to the power of minus 34 times 3.0 divided by 0.5 times 10 raised to the power of minus 9. So that answer gives us energy is equals to 3.972 minus 16. So that's it, joules. I believe that concept is not difficult. Thank you, your shadow was making that thing down. So, write it quickly. While we prepare for the last question. Now, everything we know to what? To sound waves, to sound.
One of them cancelled.
Eh?
That black for life
Where is it?
cancelled.
Okay, that's cancelled.
Okay, the giant.
Okay, so
Giant. You still see some now?
this is zoomed.
Okay, soon. No wonder.
Okay, let's do the last one. And for this last question, now they said in an electron microscope to give electrons a wavelength of 0.5 Armstrong. So this is what we're just saying. What potential difference? Now I must give you. I wrote it yesterday. small deduction. We're going to do small deduction. KE equals 1 over 2 mv square, right? I don't know if you guys are understanding what I'm saying. So automatically, m squared v squared is the same thing as what? It's the same thing as saying mv squared. That's mv all squared over m. And mv all squared is what? Momentum. So we're saying square of momentum over m. 2m, thank you. 2m, that's our 2 that was there. Now we know what momentum is. Momentum is what? Momentum is h lambda over lambda. So I can now bring it here and say h over lambda square all over 2m. And that will be giving me ke equals to what? H square all over h square all over lambda square 2m lambda square. Yes, with this now, we can now get our answer. We know that h is what? 6.62 times 10 raised to the power of what? Minus 34 all squared, based on this formula we just deduced, divided by what? 2 times what's our mass? Mass of an electron, 9.11 times 10 raised to the power of minus 31. Then our wavelength was given to us there as what? 0.5 Armstrong. And I told you Armstrong is times 10 raised to the power square minus 12. 0.5 times 10 raised to the power minus 12. You get now. So our KE is equal to what? We place it in the calculator. I'm having 6.62 times 10 raised to the power minus 34 all squared divided by 2 times 9.11 times 10 raised to the power minus 31 divided by 0.5 times 10 0.5.
Can you see the back when they come online?
Yes.
Can you watch it?
Yes. But the way it is looking here, I still looking again. So 4.8. 4.8. Our kinetic energy is 4.8 1 times 10 to the power of minus 25 joules. Now we've gotten that. Now remember that this is where we are going to. We want to get volts. They say potential difference V. So V is equal to what? Divide both sides by Q. Divide both sides by Q. So V is equal to what? KE over Q. So we're dividing this value we got here, 4.81 times 10 to the power minus 25. We're dividing it by Q, which is 1.6 times 10 to the power minus 19. That's what will give us our final answer. 1.6 times 10 raised to the power minus 19.
No, it's online now.
Okay. I can come back and watch. No, there's no 3.007 times 10 raised to the power minus 6. And that's our final answer, volts. So that's that for that. That's that for that. So we've been able to solve all the questions I wrote. I will drop questions on our group and you guys will solve them one after the other. One is for number 2 here. Here we have number 3. We have number 4. We have this. We have this too. We have this here. We have this one. Then this. All these topics they are not difficult at all. It's straightforward. It's just practice. Practice makes perfect. And this side here. All right. So that's that for that.